Hi everyone, this is Professor Bob Young, and I just wanted to discuss what's called interval notation. So it's a little different way to write your inequalities, and it's used in the upper level courses. So it's very important to learn interval notation because when you solve inequalities and you check your answers, they're going to be in this newer notation. All right, so we just want to look at some things here. And notice I've got a handout here. This can be found in your course documents. So I've got all kinds of useful supplemental handouts in there for y'all as well. And you probably have found those as you've gone through the Angel course and so forth. But in interval notation, I'm just going to make a few points here. Always arrange your intervals from smallest to largest, ascending to descending, left to right, whatever way you want to look at it. So remember what our number line tends to look like. If you go to the right of 0, 0 separates the positive and negative numbers, and I'll use colors here as well. If you go to the right of 0, 10, 100, 1,000, 10,000, 100,000, million, and so forth, the concept of infinity, which is kind of a sideways looking 8 there, is that there is no largest number. I mean, the largest number someone can think of, you could put 1,000 zeros at the end of it. Someone else could say, well, I'm going to add 3 to that, or I'm going to multiply it by 12, and it just gets larger and larger. Also, if you go to the left of 0, that's when the IRS was created, maybe, I don't know. You've got what's called negative infinity. So you could go negative a million, negative a billion, trillion, maybe to our national debt and so forth. Oh, that was a bad joke. I'm sorry. We'll get that straightened out, hopefully, in the next 100 years. All right. But anyway, what I've got here on this handout is just about every way you can write inequalities and how that would look in interval notation. So I'm just going to go ahead and get rid of the handout here, solve some basic inequalities. We'll write the answer in interval notation, and we'll graph some as well. All right, I'm going to start with a real basic inequality here. Let's take x is less than 7. All right, now if you think about the number line, I'm just going to go ahead and make a number line here because that's the easiest way to show you. 7 is to the right of 0. So if we put 0 in here as a buffer, which I like to do here, 7 would be over here. Now, all numbers less than 7, now on the number line, remember, every number to the left is always smaller than all numbers to the right. So some of you in other courses have put an open circle on the 7, and I'll just kind of put that underneath here on the bottom, and you shaded this direction. And the open circle meant did not include 7, because if you put 7 in for x, is 7 less than 7? No. So it has to be numbers less than 7. So what the open circle was replaced with in interval notation is a parentheses. So that just means does not include 7, and then we're going to shade everything to the left. So I like to use my colors there and shade. Now, which infinity are we shading towards here? We are shading towards, out here, as we go farther and farther, negative infinity. So when we write this answer in interval notation, again, think left to right, smallest to largest. We're going to come in from negative infinity, stop at 7, and notice the 7 gets the parentheses on it because it does not include 7. And infinities always get the parentheses on them because you can never bound infinity. It goes on forever and ever. It's kind of like the Energizer rabbit. It goes on forever and ever and ever and ever. All right. Now, what if that had been x is less than or equal to 7? All right. Now, that's a little bit different creature. And let's go ahead and draw the number line here real quick. It's very similar. So if we put 0 in here as a buffer, 7's still going to be over here somewhere. Now in this case, if you remember from some of your other courses, if it was less than or equal to, you put the solid circle on the 7, and you shaded everything this direction. And that solid circle meant it included 7. So in interval notation, instead of using the solid circle, they use a bracket instead of a parentheses there, and they just shade everything smaller than 7. So that's really the only difference in the two notations there. So if you were to write this in interval notation, when you look in the back of the book, let's say you solved an inequality and you got x is less than or equal to 7, you would see negative infinity comma 7 with the bracket on the 7 this time. So remember, infinity always gets parentheses, positive or negative. All right, so I'm hoping this is helping you out just a little bit. And we're going to do a few more to make sure you have it. Now, let's say you're solving an inequality here, and you say that negative 2x is less than 4. All right, solve the inequality, write the answer in interval notation and graph. So on this one, you would divide both sides by negative 2. And remembering, whenever you multiply or divide an inequality by a negative number, flip it. Flip it good. Doon, 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 doon. It's like that song, Whip It. And you get x is greater than negative 2. Now, in one of my other videos on solving inequalities, I went through that argument, why you flip. I just didn't say it's a rule and do it. I actually gave you the reasoning for it, and I think you'll understand it well. Now, if we're going to graph this, and you think about it on the number line, and I'm trying to throw some different looks at you here so you understand. Here's 0. Now, negative 2 is over here, isn't it? It's to the left of 0. Now, do I put a parentheses or a bracket on the negative 2? Well, does it have the equal sign? No. So it's going to get the parentheses, and I'm using different colors. I always like colors. And then numbers greater, remember, all numbers greater than something is to the right on the number line. So that's what the graph would look like. And if you start looking at the graph, it might make sense. If you write this in left to right order, smallest to largest, negative 2 is certainly smaller than positive infinity. So there would be your inequality answer and graph. All right, so maybe we want to make a little note here. If it has a less than or greater than symbol in it, we're going to use parentheses on the numbers. If it's got less than or equal, greater than or equal, we're going to use brackets on the numbers. So the parentheses replaced open circles, the brackets replaced closed circles, and that's all there is to it. But just to make sure, let's just do a couple more. All right, so I'm going to keep these videos short here. Now let's take one that has what's called a compound inequality that we're going to get to. Let's take negative 3 is less than x is less than or equal to 8. Now what this says is x is between negative 3 and 8 on the number line. So again, if we were going to graph this in compound inequality and write the answer in interval notation, we would put those two numbers on the number line. Of course, the negative number is to the left of the positive number. And would we put parentheses or brackets on the negative 3? Well, here's a great case for this. It would be parentheses there for the 8, brackets. Now, why, young? Why brackets on the 8? Well, it's got the equal to in it. So there is your whole lesson in a nutshell. And shade all numbers between. So I had a guy I knew from Tennessee I used to teach with, and he used to call these tweeners. In Tennessee, he goes, X is tween them numbers on the number line. So that's how he would always call them. He goes, that's a tweener problem. So here is the answer when you look in the back of the book, if you were to solve this, which you will be solving these type of inequalities and getting answers. My bracket's not looking nice and sharp there, is it? Try to make that nice and sharp looking. All right, so that is a brief lesson on interval notation. And remember again, every single type that you may see inequality notation here, I've went ahead and I've made on the handout here a graph and what it would look like in interval notation. So this is Professor Bob Young signing off. make sure that you start using those parentheses, brackets, and infinities well. Take care.